Yes. Now, you have already listened to a number of presentations about digital tools, digitalization, and also how it is practiced, last presentation by Simon. So, I'm going to talk about the drivers, opportunities, and challenges. A part of this will be general, but I will also take some examples which probably is going to be interesting for you, those of you who are coming from utilities. So I'm going to cover the digitalization world and opportunities for our sector, challenges, which means the threats with digitalization, because it is not only the positive side, and the best practices. So if you look at the water sector, how it is changing. The world is changing. The world has already changed with digitalization. Like when we were at the school or the university, we didn't know how important a mobile phone would be. And today it has taken over our world. We can't even live without a mobile phone. So I think it's the same thing is going to happen with the digitalization. What we see today is not the end. So what's going to happen in 5 years' time or 10 years' time, which is very difficult to predict, but what we know is that digitalization is here to stay. So whether you like or not, we have to accept that the world is moving and we will have to embrace digitalization into our activities. So many utilities have achieved a lot, but there's a huge underutilized potential. So this is what we have to understand, that we have to work for. Digitalization is not new for our sector. We started working with digital tools like models maybe 50, 60 years ago. So if you remember, the first hydraulic models, they were constructed in 1950s. And of course now it has increased a lot. We are working not only on hydraulic models, but a number of other tools. There was also an uncontrolled digitalization process we all experienced. This was during the COVID-19 pandemic time. So we were caught in a situation where our operators or the managers could not go to the treatment plants. At the same time, as service provider, the water supply systems and wastewater, we had to provide our drinking water to the population. How would we do that? By that time, most treatment plants, most utilities, they had functioning SCADA systems, and many functions were automated and also could be remotely controlled. So what we did was that we gave the authority or the possibility for operators to monitor the process and also to control certain elements of our treatment processes. The downside of this is that we have given this access to our operators without having a proper training and also without giving proper equipment. So the result is that they don't have an understanding of the cyber threats. Sometimes they are using the laptops of PCs which their teenagers are using, or the teenagers are using their PCs. So by that we have opened completely a new risk area for our utilities. I'm going to talk a little bit more about that, what we have experienced and how we can manage these problems in the future. So the other thing is that vast advantages, what we see with the digitalization, might make us to forget the downsides of digitalization. And the unplanned digitalization, many of it is that I'm referring to what happened during the COVID time, and also maybe even now, some plants are getting carried away, maybe also because of the suppliers are coming up with various solutions, and they're putting up, and they might also say that this is fully functional and these are safe, but you have to be sure that your systems are not vulnerable. So if you look at the water circle, from where we take our water from a river or a lake or groundwater, and then we transport it to our treatment plant. After that, we distribute it to our consumers, households or industries, collect the wastewater, treat them, and dispose them back to a water resource or the reuse. Each and every part of this circle, there is a possibility to have a digital tool, right? So there were some examples shown by Simon, and we can make our systems smart and having not only smart control, but make the whole thing more efficient. Including the predictive maintenance, which was also mentioned by the previous speaker. So during the last decade, if you look at, and then our process understanding has increased, and process control tools have come into the market. It's not only a few treatment plants who has got SCADA systems, but most of the treatment plants, or I would say all treatment plants now have SCADA systems, and we have the possibility to improve the processes. So here we can use online sensors and advanced control systems and increase process knowledge, and all of this together makes and also the data what we have from operations make us capable of changing our world, also using the new tools as artificial intelligence and machine learning. So the second part is to look at the opportunities for the water sector, and they are quite a lot. I cannot list all the opportunities or the positive things where we can use digital tools. So for example, remote watershed integrity. So we don't need to wait until we observe our raw water is not good enough or some accident happened. The water quality in our lake or river has deteriorated. We can already place inexpensive sensors out in the watershed so that the drinking water plant can know that what is the quality of incoming raw water. Treatment process optimization, and here as it's noted, the water quality sensors, both physical and virtual sensors. I will explain what is an individual, what is a virtual sensor. And when you combine them together in algorithms, we can optimize the treatment process and we can reduce the operational costs. It is important to reduce the operational cost. It is important to reduce the manpower as well, because many countries experience the lack of manpower. So we need to find ways to reduce that without deteriorating water quality. And the reduced operational cost is also important. We talked about the cost recovery yesterday during the workshop, and we have to look for all possible ways to reduce operational costs, because the operational costs are going to be increased in the coming years, partially because of the EU directives or the legal regulations, and partially because also that the way that we operate and our ambitions. So, for example, EU directives require that consumers, or the EU directive says that the consumers have the right to know the water quality, what they get in the tap. It is not fully implemented, but what we do today is that most treatment plants, they do an analysis once a year or once a month, and they publish the water quality data. But in the future, it is not going to be accepted by the consumers. We would like to know in my mobile phone what kind of water I'm going to get in my tap. And then we can say that yes, of course, we can do the analysis at the treatment plant and we can publish that. It is also not good enough because while it is transported from the treatment plant to your home, water quality gets deteriorated. So which means that you can't, based on physical sensors or the laboratories, or especially the laboratories which gives you analysis after some time. So we are talking about a revolution of digitalization and real-time monitoring of water quality in the future. Water network management, sensors and algorithmic solutions provide monitoring of network pressure, failures and overall asset condition, which was also shown by the previous speaker, how this type of systems and using an equation, well, that equation is the basic equation. Of course, you have to calibrate it and you have to put them into some input with AI and machine learning to make it work. So the point is that today, if we look at how we invest money in the Norwegian conditions, each municipality is saying, they can say that yes, I'm using 10 million or 50 million euros to rehabilitate our sewer network. But how do we choose where to rehabilitate? The first thing is that where we have damaged pipes. The other one is not sure where we should do it, where should we give the priority. But we can use these digital tools to predict the age and the potential damages which are going to happen in the future. Combined sewer overflow management, how to reduce the flash floods and also pollution coming from rainwater. Preventive measures, predictive maintenance, stormwater management and flood relief, intelligent pumping and treatment equipment. So these are some examples. So you can read more about these in the IWA. There's a digitalization, digital water section. There are a lot of white papers and documents. You can read more about that. So I would like to take one example of a tool which you can use in your treatment plants or your water network or sewer systems. So there are many accurate and affordable sensors, but they require maintenance. Anyone who has worked with pH electrode, they know that you have to maintain, you have to calibrate it every week. Although most of the, in many treatment plants, they don't do that. I have visited some treatment plants in Norway where they haven't checked their pH electrode for 6 months. And when you are moving into the processes controlled by sensors, you need to know that most sensors, they won't work 24 hours per day, 7 days a week, 365 days a year. And we don't have online sensors for all parameters. If you take the phosphates, we don't have an online real-time concept for measurement of phosphates. Of course, what we have is an auto-analyzer which can give the phosphate values after 10 or 15 minutes and costs like 50,000 euros. That's why I say that many systems are not affordable. And difficulty in predicting treatment results, we can't say much about the predicting results because in wastewater treatment systems, we are talking about maybe 5 hours, 6 hours, maybe even even longer time from we get the water and when the wastewater is out. So we don't know what's going to happen, and when we finally see that water quality is not good enough at the inlet, it is too late to do changes in the inlet because the water quality, inlet water quality have changed. So here are two simple flow sheets showing the conventional water treatment process at the top, and the below is the chemical biological treatment with post-precipitation. Before, or even now, I would say before, it was enough to check the water quality at the outlet of a drinking water treatment plant, look for the particles, the media suspended solids, look for the color, natural organic matters. pH so that it is not corrosive, and also check whether the water is infected. Wastewater compliance reporting is COD, BOD, nitrogen and phosphorus, that's all. But this is now changing. It's not enough that we measure the water holding outlet, but we need to measure it in inlet and also in between processes so that we can optimize each and every process. And then the question is, can you afford to have physical sensors? Most treatment plants, they can't even afford to have sensors, the outlet. How are we going to optimize the chemical part or the sedimentation tank or the filters or the biological stage without measuring the incoming and outgoing water quality? To do that, we need to have sensors. And the concept of soft sensors or surrogate sensors or software sensors or virtual sensors, this is something that started about 10 years ago and it is now evolving. An example, simplest example is if you have seen a suspended solids sensor. Suspended solids method measurement is that you take a sample and you have to do this analysis in the lab. So below it's a suspended solids measurement method. So you take a sample, you filter it, and you dry the filter, and you weigh the filter, and then you divide it by the amount of water which you went through. It takes like 2 to 3 hours to get a sample. But turbidity, it is the measurement of the light diffraction, and you can get a sample, put it to the turbidimeter, and within a second or two, you get the result. So how do these suspended solid sensors work in practice there? There is a linear relationship between the turbidity and suspended solids. So this is documented, and especially for specific water type, it is quite good. So the suspended solid sensors, they measure the turbidity, but they convert it to suspended solids in an algorithm, and they show the suspended solids value. The same way you can do it for other parameters. So here you can have some, let's say, simple and inexpensive parameters like pH, flow, rate, level, suspended solids, conductivity, temperature, redox, and then we can have some algorithms, AI or ML-based, and then at the end you can get the COD, BOD, phosphates and nitrogen values. So we have worked with this system, and there are some complications you can read if you want, and we can now predict the COD, BOD, phosphates and nitrogen species for more than 90% accuracy. And they are now implemented in some plants in Norway and some plants in China. So this is a dashboard in a treatment plant which shows the real-time measurement of COD, BOD, and also the treatment efficiency. And so we say that hybrid because it is not only a digital model, but it is a combination of real-time measurement of some simple, inexpensive parameters, and then combine them in prediction. Digital twins, I'm not going to go there, it's shown here, and it is a combination of, get the data, put into the model, and analysis, and then also combine it with the 3D models, and so that visualize the operators and others, they will get a better understanding. So these are some examples. If you want to know more about that, please contact me. I can give some information about that. The last part is the Chinese. This is a famous picture of a screen by the Norwegian artist. Now the water and wastewater or the water infrastructure is considered as critical infrastructure in most countries. Critical means that then something happens, then the emergency or the special ministries and agencies taking over. Right? So we have responsibility to do that. And the cyber attacks, it is not new. So it's like 20 years ago we saw the first attacks, and since then we see a lot of attacks happening in our water sector. Most of our attacks are not reported. So what can cyber attacks do? So the simplest one is drink water treatment plant. You know that you have to add so much of chlorine, and the operator sees that this is the amount of chlorine added, but a hacker could go in, say that reduce the dosage by 50%, but show the 100% value. So what happens is that the water which we send to the consumers are not disinfected. And imagine a city like Brussels or another city, big city, is having half of the population having diarrhea next day, right? So the whole system will be collapsed. So you don't need to have bombs to disrupt the society. To do that, not everyone knows all these things. So managing cyber threats is important. Unawareness is the first thing that we have to get rid of. When I ask utilities, they say, no, it's fine. No, it is not. If you don't know, you are not prepared, and then it's not going to work. You can't solve these things when you are on that track. You have to be ready to this. And to do that, there are many tools available, and I'm sure that these things will also be formalized in national rules, and EU is working on that. And there's a lot to be done, a lot to be gained, a lot to be careful about. Thank you very much.